All right, in this example, we have a function 4 minus x squared. And the first thing we need to do is just complete this table and sketch a graph of the function. So I'm just going to plug the numbers into the formula. I'm going to put these numbers in for x, and we'll see what we get. So if I replace x with a minus 3, right, then I'm going to get 4 minus, and when I square negative 3, that's a negative 3 times a negative 3, which is 9. So it's 4 minus 9, which is a negative 5. And then we just want to do that for all of these values. All right, so I went ahead and completed the table so that you don't have to watch me do all these calculations. I'm sure you can do these calculations. The one thing to be careful of is just when you're squaring a negative. And in this one, you probably didn't have to put it in your calculator. But when you put it in your calculator, if you were to put it in your calculator, when you're squaring a negative number, make sure you put parentheses around it, because if you, just like I said down here, if you, if you square negative 2 and you type it in negative 2 squared, it's only going to square the 2 and it's going to keep it negative. But what you really meant was the whole thing negative 2 squared, right? You're substituting negative 2, so you want to square the whole thing, which is negative 2 times negative 2. It's going to be a positive 4. That's a very common mistake that I see happen. So I just wanted to make you aware of that. All right, now we just need to graph this function. So I'm just going to take these points, take these coordinate pairs, x and y, and plot these values on the graph. So well, I went ahead and drew my axes, and I should probably label the axes because I need a scale, right? So 1, 2, 3, and then negative 1, negative 2, negative 2, negative 2, negative 3. All right, so I went ahead and put the scale on the axes so you don't have to watch me do that. And then I plotted the points, right? I plotted all of these points. Negative 3, negative 5 is right here. Negative 2, 0, negative 1, 3, and then 0, 4, 1, 3, 2, 0, and then finally 3, negative 5. Okay, and then I connected it with a curve. So there we go. We've graphed the function. And what do we need to do now? The next thing we need to do is draw a line segment whose slope represents the average rate of change between x equals 0 and x equals 3. Okay, so we're just going to draw a line segment between those 2 points. So let me scroll back up just a hair. And let's see. I know I probably can't draw a straight line, but you can imagine if this is a straight line, I've got to go from 0 to 3, right? This point 0, 4 to the point 3, negative 5. And I try to draw a straight line. Let's see how well I do. Oh, okay. Yeah. So this is why I stop the video, because it's just, all right, there we go. Pretend that's a straight line. All right. So that line segment would have a slope that is equal to the rate of change between those over that interval from x equals 0 to x equals 3. All right. Then it's asking, is the average rate of change from 0 to 3 positive or negative? So if the average rate of change is the same as the slope of that line segment, right? If you look at the rise over run of that line segment, it looks like to go from 0, 4 to 3, negative 5, you go down by 9 and over by 3. So it's a negative 9 over a positive 3. So, and you can tell because it's sloping downhill as you go from left to right. So the average rate of change over that interval is negative. Okay. The next thing we want to do is calculate the average rate of change. Well, I just said it was, we had a a negative rise of 9, right? A negative 9, and then over 3. But we can just, we want to calculate the change in y over the change in x, right? So we can also just take f of 3. F of 3 is negative 5 minus f at 0, which is 4 over 3 minus 0. All right. So that gives us a negative 9 over 3, just like I said, and so that's a negative 3. All right, so the average rate of change over that interval is a negative 3. All right, now we want to do the same thing for the interval between negative 2 and 1. All right, so I'm going to try to draw a line again here between x equals negative 2 and x equals 1. So let me just kind of draw a line here. All right, pretend that's a line. All right, that's my line segment. And again, the slope of that line is the rate of change of the function over that interval. So the next question has to do with, is it positive or negative? Well, here we have a rise to go from negative 2, comma 0 to negative 1, comma 3. We have a rise of 3 and a run of 1, right? So it looks like it's a positive slope, it's going uphill. So in this case, the average rate of change is positive. All right. And then we need to calculate the average rate of change between those 2 points. All right. So I'm just going to look at, so we're going to have, again, delta y over delta x. So I'm going to take f at negative 1, which is 3, minus f of negative 2, which is 0, and then over negative 1 minus a negative 2. All right, so I have 3 over, so 1 minus a minus 2, that's 1 plus 2, which is just 1. So that's a slope of positive 3. All right, I'll meet you in the next video for the next example.